Now what I like to do is talk about some specifics with respect to Ohio. Well, okay, I don't want to talk about Iowa. I want to talk about Ohio. And this data that I'm sharing with you in this video all comes from the Tri-State Fertilizer Recommendation Guidelines that you can find easily online for free. So here is a table, Table 28, the recommended MELEC-3 extractable soil test critical levels for calcium and magnesium. Right, so we talked about MELEC-3. It's a multi-element extractant that can remove a portion of calcium and or magnesium from the soil that we as soil scientists think represent what concentrations feed a plant, right? And so in Ohio, we look at critical levels for calcium and magnesium. These are the levels where above these levels, calcium and magnesium are sufficient. And the sufficiency is dependent on the soil type, or more specifically, the cation exchange capacity and or texture. So this is the puzzle, right? This is the soil fertility puzzle we're putting together for you, that CEC and texture go hand in hand to discern or identify the needs of calcium and or magnesium in our soils. So for coarse textured soils or finer textured soils, with respect to calcium, the critical soil test concentration is 200 parts per million. And for magnesium, I told you in a previous video that 50 parts per million or less typically will show or can show a magnesium deficiency. But in Ohio, it's been found that under coarse textured soils, the level is actually a little bit lower. It's at 35. So some other specifics for Ohio. For calcium specifically, maintaining proper pH range via liming maintains proper calcium concentrations on the cation exchange sites to act as a buffer for calcium when it's removed from the soil solution. So what I'm telling you is that we oftentimes lime our soils to raise the pH, so to put the pH in the range that's necessary for plant growth and offset the issues that we might see with aluminum toxicity. And by doing so, we oftentimes use a liming source that contains calcium, right? In fact, all of our liming sources contain calcium. And so we don't really add calcium as a fertilizer, we add it as a liming agent, and we get the added bonus of adding calcium to our exchange sites. Magnesium. Low magnesium levels or concentrations could be found in eastern Ohio, because our soils in eastern Ohio are slightly acidic. And large calcium application rates or high levels of exchangeable potassium can actually reduce magnesium uptake. So this is something to be concerned about when we lime soils in eastern Ohio, right? Magnesium, it says point letter A under number 2, magnesium to potassium concentrations expressed as a percent on the exchange sites. If it's less than 2 to 1, this may reduce magnesium uptake. And so another way of thinking of this point is that when the amount of potassium increases on exchange sites, the ratio will be less than 2 to 1, right? It actually will be 2 to 2 or 2 to 3 or 2 to 4, but you get the idea. All right. And so if it's less than 2 to 1, then we have an issue. Another way of looking at this is that there simply is not a lot of magnesium on the exchange sites as compared to the amount of potassium on the exchange sites. Most magnesium deficiencies certainly can be overcome by adding dolomitic limestone. We need to add a source of magnesium, and magnesium can be added via dolomite, which contains both calcium and magnesium. And then there's a kicker, all right? So if we talk about both calcium and magnesium together, so excessive potassium in soils can reduce the uptake of both of these elements. So you think about what's happening on the exchange sites. Excess potassium on exchange sites means there's less buffer of calcium and magnesium on the exchange sites to buffer the removal of calcium and magnesium from the soil solution. Okay, so that's what's happening with excessive potassium. This is the interplay between these three elements. Letter A states that forages with high potassium or low magnesium concentrations can actually lead to grass tetany, milk fever, and other problems with ruminants. And we mentioned these issues in a previous video in this unit. So what I want to do for the last slide in this video is to go back to this soil test result and reiterate what was expressed on one of the previous slides in this video, that the magnesium to potassium ratio expressed as a percent on the exchange sites of less than 2:1 may reduce magnesium uptake. Less than 2:1. So here we need to go back to this percent saturation and look at the ratio of magnesium to potassium. And are these ratios less than 2:1? No, they are not. This is greater than 2:1, certainly greater than 2:1, so forth and so on. So in this soil, we likely are not going to see an issue with magnesium. And I can tell you that there is not an issue with magnesium with respect to plant growth in this system because I've worked with these soils before.